Thanks for tuning in and welcome back to the basement. Yeah, it was a little too cold out here yesterday, so I figured I'd spend the day in the basement tackling a little project that I've had in the back of my mind for a while. In one of my recent journeys down a rabbit hole on Amazon, I came across a super cheap inclinometer. For the price, I knew it wasn't going to be anything amazing, but I figured it would be fun to rip apart. Based on those dimensions in the ad, I bet you I could make that fit into a gauge hole on the dash. To the Sketchup. You may have noticed that quite often I'll run into a part that I want that just doesn't exist. And that's where I love having the ability to draw stuff in SketchUp and create it on my 3D printer. Instead of just drawing it and printing it this time and showing you after, I thought I'd run you through the process of how straightforward it really is to create a 3D part in SketchUp and produce it on a 3D printer. So here we go. I need to make something that matches the diameter of the hole in the gauge panel. To start, I need to select the circle tool, and before I draw the circle, I'm going to tell it to have 128 sides. The larger the number, the smoother the circle is. Next, I'll click pretty much anywhere on the screen and drag along one of the axes, and then set my diameter by typing 26. This is going to give me a 52mm circle. Next, I want to give it some width, so I'm going to offset, and again typing in the distance I want to offset as 2mm, and this will give me a 2mm thick ring. Now I can get rid of the center. You can see this is two pieces, the center and the outside. I just need a tube. Now I have a flat ring that I can extrude upward to get into a tube. I'm going to make this 20mm tall, but it's not that important because I'll be trimming it off. Well, hang on, if I'm assuming that this is going to fit in a 2-inch gauge hole, why am I going to all the trouble of a tube? Well, if I just shove it in there as is, I'm going to be measuring the angle of the dash. So, what's the angle of the dash? So I took my little scale and I put it up against the dash, and I know you can't read it on this angle, but it says 21 degrees. Now I want to make some reference marks, so I'm going to draw a line from the center and use that as a reference to come up on the side by 2mm. Now, these are only reference lines, so once I have that 2mm line, I can delete all the other lines that I used. Anytime a line crosses a line in SketchUp, it makes a new line segment, so you need to go and remove all of the pieces of the line. Now that I have a reference 2mm up, I can draw a flat plane. So I'm going to draw a line out along the red axis, back along the green axis, and the length of these lines isn't really very important. Now I'm going to take this line and I'm going to rotate it. By picking the rotating tool and then using the left, right, up, down arrows, I can change the axis I'm rotating on. Now I want to rotate this on the red axis. First I click the origin of the rotation and then I click and drag up. Now I'm entering manually 10.5 degrees because that's what I want to rotate. I hit enter and there's my new line. Now I want to duplicate this line, so I'm going to select it, I'm going to pick move, and then, well, no, actually I can't do that yet, I've got to draw my line over here. So now I'm going to move, so I'm going to select the line, and then I'm going to go to move, but I'm going to hit control, and you'll see a little plus, and that means I'm duplicating instead of moving. Now I can draw a line across the top, and this is going to create a plane that slices through the tube. Well, maybe more accurately, they pass through each other, and I need them to intersect. So I'm going to select the whole thing, intersect faces with selection, and now they slice through each other. This plane has now served its purpose in allowing me to slice through the pipe, so I can delete the plane. Select the whole thing, hit delete, remove my lines, and I end up with just the circle. You may recall when I extruded this pipe, I didn't really have much concern for how high it was, and that's because I'm deleting the top half anyway. This is the piece that I want. Now you can see when I click this, it's actually the inner and outer surfaces are highlighting together, and I don't want that. For some reason, they haven't quite joined. So again, I'll intersect faces with selection, and this should make sure that the ring on the outer ring and the inner are separate, and I can now delete the inner ring to end up with a sliced tube. Before I go any further, I'm going to make this into a component. So I'm going to select everything and I'm going to make component. And this means all of these parts will act as one. So if I try and move it around or duplicate it, I can't accidentally grab one part of it. As you see, if I click, it's all one piece now. So next I'm going to duplicate this so that I have two of the same piece. Now that I have two identical pieces, I want to flip this one over. Picking the green axis, I pull out to the side on the red axis and flip it back to the red axis. That's a 180-degree flip without entering any numbers. Next, I'm going to rotate it again, but this time I'm going to rotate it on the red axis and by 21 degrees. Now I can select this part, copy it based off the reference point of the center line that I left on it. I can pick this point here, and I can move it over to match exactly on top of the other one using the same reference point. This now gives me the two pieces miter cut placed together to give me a 21-degree wedge. Because these are two individual pieces and I want them to be one, I'm going to again select them both, go to intersect faces, and pick with selection. Now I'm going to take the two pieces, select them both, and create a new component so that I can move them around as one piece. And I think you get the idea of how this is going to work. This, of course, would work really well if I was just gluing pieces together, but I want things to snap together the same way my panel will snap into the dash. So I'm going to select this whole thing and I'm going to explode it back into its original parts. So you can see I've gone back down to the two wedges. I'm now going to explode each wedge so that it goes into its individual parts so that I can continue on with the next piece. So you can see I'm back to individual pieces for each piece. Next, I'm going to extrude the piece that goes down inside the panel. So again, I'm going to offset this ring to the inside by, we're going to go 1 millimeter this time. And sometimes Sketchup doesn't know which surface you actually want. So to fill in that gap, I just need to draw a little line from one edge to the other, and it'll fill in that little ring that's missing, which is actually the piece that I want. Once it's created that, I can go back and just erase the lines that I used. So this line here doesn't really need to be there, and nor does that one. Those are removed, and then I can remove the center, and I end up with the little ring that I originally wanted. This ring is going to be the piece that goes down through the gauge panel, so I also need to extrude this down. Now you can see we've got a sleeve that fits down inside the gauge panel. Again, Sketchup didn't quite know what I wanted to do here, so I need to add a little line to re-add this upper surface. Just adding the line and then erasing it after will give me the surface back. If I were to print this part like this, it would be extremely weak, so I want to add a little gusset here. So I'm going to pull a line 1.5 millimeters up, and then I'm going to make it into a triangle, and I'm going to use a pretty neat tool here. With my triangle drawn, I'm going to go into the menu at the bottom and I'm going to select Follow Me. Right there. This allows me to click the surface and drag it around the circle, and that gives me a fillet all the way around. That is a really easy way to add a bit of strength into this part. Right now this would slide nicely into the panel, but it would also slide back out again, so I need to make some little tabs to hold it in place. I'm going to start by creating a reference line on the front. With the reference line selected, I can now copy the lower ring. Again, this is just as a reference. I can copy the entire lower ring and I can slide it up the side using my reference line. So I've picked Move and then I'm going to select Control to copy, and I'm going to use that line to slide it up by 4.5 millimeters. Next, I'm going to make the little wedges. So I'm going to pick my reference point at 4.5 millimeters up, and I'm going to draw a line out along the green axis that's 1.5 millimeters long. And it's really important that I do this along the green axis. So I pulled out along the green axis and I enter 1.5, and there's my 1.5 millimeter long line. Now I can turn this into a wedge the same way I did on the inside, and I have a 1D tab. Again, I'm going to use the Follow Me button to drag this along the outer surface. Now, Sketchup is limiting how far I can drag this. There's probably an issue with the number of segments in my circle, but this tab is perfectly fine and it's going to do what I intended it to do. Now I'm going to repeat the same thing on the back side, and I'm going to make two more, one on each side. So I'll drag this line across the green axis right through my part, and that gives me the indication of where I need to draw this one. Now for some reason when I created this part, Sketchup made it inside out. As you can see, these pieces are dark gray instead of white, so I need to select each of the surfaces and I need to actually do what's called a reverse faces. I have now effectively turned that part inside out, so when I try and slice it in my printer it won't get confused and try to print the outside on the inside. With all four tabs created, I can remove the excess material on the inside, and it looks like we now have a finished part. Lastly, before I export this model, I want to once again select everything and make sure I intersect faces. This means that all the lines that should be touching will be touching. That should give me one piece, and I'm going to lastly make it a single component so that I can move it around in my workspace without leaving pieces of it behind. And I should do one more thing. I'm going to select the entire model and I'm going to rotate it by 21 degrees, and that'll mean that the bottom face will be flat when I import it into my slicer, so I don't have to rotate it in the slicer every time I want to print it. After downloading the STL file, I have imported it into Cura, which is the slicer that I use, and I'll take a look around and make sure there aren't any areas that look wrong, like this little red area here. Cura uses red to show areas that may not print properly. It doesn't mean that they won't, it just means that they might not print properly. Looking at these areas, I'm not that concerned. They're very slightly overhanging, And because of where they are, it doesn't really matter if some of the filament on the first pass hangs down a little bit. It's not going to impact how the part works. So I've made sure that I have the right filament. I'm adjusting a couple of things. I don't need this part to be super strong, so I'm going to reduce the infill down to 10%. And let's see what we get when we hit slice. So it goes through and figures out what needs to happen. It's going to say about an hour and 27 minutes to do this. Now I always go to the preview tab and I look at what it looks like for the printer. So this is the actual lines of the filament. And I can go down through the layers so I can see what it's like inside the walls and as it goes up through the layers. One of the things that I look at quite often is the type of infill, especially because this is a pretty thin part. So inside the walls, what is it doing? And I can see there's a lot of empty space, which is gonna have a hard time supporting the layer above it. I think I'm gonna try reslicing this with a different type of infill. So I'm going to go up to the menu and instead of grid, I'm going to go to zigzag. I use zigzag fairly often and it does seem to come out quite well and usually saves a bit of time. Saved about 5 minutes, but the big difference is inside the walls. There's much better support in here, it's more frequent and more consistent. So I think this is a much better choice for the type of infill to be used. Now I'll save this to the disk and then we'll go and open it in Octoprint. I've already started the bed heating, but I'll turn on the extruder heat at this point, and I want to set it to 240 degrees to start with, and that's going to get things warming up as I load the file and make sure that everything looks the same when I look at it in the printer. And it does. I can do the same thing here. I can look at the layers, I can go up and down to make sure that the infill still looks right. It usually does, but sometimes I catch something at this step that I haven't caught in the slicer. So now I'm going to check that my camera is working, and I'm just going to wait until that temperature comes up and then we can hit print. There are a lot of options for the surface you can print on, but I've found that the glass bed works perfectly fine. The first layer is the most critical, so it's even slower, but once that's down, it's off to the races. And an hour and 23 minutes later, we get to see if what I've drawn actually works. But first, how hard is it going to be to rip this super high quality inclinometer up? Never mind. Now we have a printed 21-degree housing and separated the guts from the old inclinometer. Let's fit them together. That's about as easy as it gets. Let's see how well the housing fits into the switch panel. Pretty much the same, it just pops right in, and the 4 little wedges do their job of holding it in place. I'm going to rotate it to make sure I have the shortest section at the bottom, and now I can pop the guts of the inclinometer back into place. I'll have to do a final side-to-side leveling adjustment once it's in the truck, but it just needs a twist to get it there. Now let's see how it fits. There we go. Looks like I've got to do some adjusting there. But that now tells me my truck is level. I think that'll work all right. It's not going to be perfect, and really, I'm not going to use that driving down the road. The idea behind that is more for getting level when we're parking to find somewhere to sleep that's nice and level. So I can put a couple shims under a tire and drive onto them and hopefully take a look at that and see that we're level. I hope you enjoyed that video. If you did, consider giving us a thumbs up. Subscribe if you haven't already. Don't forget to check the video description for any of the useful links. Thanks for watching, and we'll see you next time.